Hi there and welcome to this video. In this video, I'm going to share with you the history of quality statistics and the history of industrial statistics as well. And I'm going to do this because I'm sure that understanding and knowing the history of these methods will help you understanding why these methods are still and always will be so important in every field of industry and of services, not only manufacturing. So let's get started. It was in the very first years of the last century that Henry Ford was wondering on how to improve quality, how to improve productivity, and how to inspect process quality. Just think of it. It was the very beginning of the 20th century, and Henry Ford was already facing these problems in his company, and he found out very interesting ways to approach these points, improving quality, improving productivity, and so on. That was just the beginning, but in those same years, AT&T began systematic inspection and testing of products and materials, and they did this because inspecting materials and their quality was already so important for the whole quality of the company. Also, in 1908, William Gosset in Dublin, writing as student, he introduced the tea distribution as a result of his work on quality control at the Guinness Brewery. This man made the history of statistical quality control. He created the very roots of statistical inference, and he did a really great work on the topic. In the 20s, AT&T Bell Laboratories, they did form a quality department. Just think of it. It was just the 20s, and the quality department was formed at AT&T Bell Laboratories, and they emphasized quality, inspection, test, and product reliability. In the same years, General Electric used statistical methods to control the quality of electric lamps. It was 1920s. Just think of it. In the same years, between 1921 and 1925, Mr. Ronald Fisher, here he is, did publish series of fundamental papers on designed experiments and their application to the agricultural sciences. It was the first use of analysis of variance, and it was as well the consolidation of statistical inference. It is very interesting what Fisher did think about the role of a statistician. He said that consulting a statistician after an experiment is finished is often merely asking him to conduct a post-mortem examination, because when things are done, a statistician can perhaps say what the experiment died of. These were the words of Ronald Fisher, who basically invented the design of experiment. In the same years, we had also Walter Shewhart. This man, in 1924, introduced the control chart concept at the Bell Laboratories in a technical memorandum. While control charts are a graphical tool that today everybody should know, it is something like this. And it was revolutionary by those times because it was a very easy to use and easy to understand tool that was definitely new, because the concept of statistical control of a process did not exist before 1924. It was invented by Shewhart, invented using the concept of control charts, which are based on a solid statistical basis. It was 1924. A little bit of years later, in 1928, Dodge and Roming, they did invented a acceptance sampling methodology. This is very important because given that you receive a lot of items from your provider, then you have to know how to inspect the lot in order to understand if you can accept the lot or if you have to refuse the whole lot. And this is done using a solid statistical approach, which was invented by Dodge and Roming in 1928. Please consider that the same method is the method that you can use when you are the one that is going to ship a lot to one of your customers. Is the lot made up of good items? You have to inspect everything, or maybe you can use some acceptance sampling methodology in order to understand quickly and in a cheaper way if the lot can be shipped or not. Yes, you can, and the method was born in 1928. Then we had World War II, and during the years of the war happened a lot of things from a statistical point of view also. That is the point of view that we are focusing on in this video. The US War Department published a guide for using control charts to analyze process data, and the Bell Laboratories, they developed the forerunners of the military standard sampling plans for the US Army. And design of experiment had its ultimate growth because it was used everywhere to optimize products and processes. So we could say that design of experiment was developed and did grow on the battlefield. It is definitely true because even if it was born before the war, it became a must-have method during the war because it was really successful in providing good results fast and in a cheap way. And also in those years, the Monte Carlo method was I could say that it was developed throughout the years of the war, but it had a great success story within the Manhattan Project because it was the approach, the mathematical approach that led Fermi and his team to develop the nuclear bomb before the Germans. After the war, in 1946 and years coming after, William Edwards Deming, he was invited to give statistical quality control seminars to Japanese industry. Consider that 2 years later, in 1948, Junichi Taguchi began study and application of experimental design, and he invented a very advanced kind of design of experiments, which is called Taguchi design. And Taguchi design was really one of the most advanced design of experiment methods for decades after 1948. It was really, really advanced. Deming began education of Japanese industrial managers, and statistical quality control methods began to be widely taught throughout Japan in the 1950s. In the same years, Ishikawa introduced the cause and effect diagram. This story is meaning that Japan did start to go fast forward from an industrial point of view immediately after the Second World War. And this is history. Back in the 80s of the last century, Japan was really the best country in automotive and electronics because they used statistical methods since 1946 everywhere and for every kind of process and product. And this is what made the difference for decades worldwide in the automotive and electronics businesses. Then, between 1975 and during the 80s of the last century, books on designed experiments oriented toward engineers and scientists began to appear. Experimental design methods were introduced to and adopted by a wider group of organizations, including electronics, aerospace, semiconductors, and obviously automotive industry, because Japan was teaching the world how they faced the problem and the results, the amazing results they were having. And in 1987, Motorola introduced the Six Sigma methodology, which will be spread then to other industry about 10 years later. Six Sigma was Motorola's way to answer to the great power of Japanese electronic industry, where statistics was already a must for decades. So that's it. So now that you know that there was more than 1 century of development of these methods directly in the businesses, maybe you can better understand why these methods are really, really powerful and why it is really an investment for you and for your company to get an expertise with these methods.